Okay, we'll be doing page 70 again. So on page 70, we have specifications there. Timber for trusses 38 by 114 pre-treated South African pine. Trusses spaced at 750 millimeter centers, 114 millimeter by 39 wall plate, 52 by 76 millimeter sawn per lines, 76 by 76 rod eave per lines, 600 millimeter overhang at eaves, 100 millimeter overhang at gable ends, fiber cement shaped roof covering, fiber cement rich piece, 15 millimeter by 200 fiber cement fascia board, and 10 by 200 barge board. Roof pitch is 30 degrees, brick wall 220 millimeter thick and faced externally. So they want us to draw to a scale of 1:10 the half roof truss. There it is there, we've drawn it. So we're going to start with the gable wall. So gable wall, here it is, here is the gable wall. A gable wall consists of two shapes which are a triangle and a rectangle. We have the size of our rectangle, which is 195, and then we have the size of the height of the whole gable wall, which is 1270. So since the gable wall consists of two shapes, we need to divide these two shapes into two. So we deal with them separately. So we're going to start with the triangle. So the triangle, the formula for triangle is half base times height. So what is our base? That is 3732. Where do we get this 3732? We have a diagram that we are given here. So this 3732, the width that ends where the wall ends, this is our wall. The width that ends where the wall ends is the width of the gable wall. So it's 3732. And then how do we get the height of the triangle? We have the height of the gable wall, which is 1270. There it is there. A gable wall starts under the wall plate. Here is our wall plate, and as you can see, this dotted line here represents the wall plate, under the wall plate, where the wall plate is starting. So from the wall plate until there, at the top, it's 1270. It's the height of the gable wall. So for us to get the height of the triangle, we're going to say height of the gable wall, which is 1270. We subtract the height of the rectangle, which is 195, and then we'll get 1075. That is our height. So it's half base, which is 3732, and then the height that we got by saying 1270, height of the gable wall minus height of the rectangle. So it's 1,08. And then remember that this gable wall, if we are dealing with a house that has a gable wall, it means at the front there will be a gable wall, and also at the back there will be a gable wall. So this gable wall is just for the front. So we need to multiply by 2 to show that it's at the front and also at the back. And then we are done with the triangle. Now let's dive into the rectangle. So for rectangle, it is the width and the height. This is the width. The width of the rectangle is the same width as the triangle. The triangle is sitting on top of the rectangle, therefore the base cannot be different. So 3732, there it is, that's our base, and then we have 195. When you have redrawn the roof to scale, you will get the 195. So the 195 starts under the wall plate. Where does it end? Somewhere here, so it's 195. It's for the rectangle, okay? Rectangle, and then the triangle. So we need to multiply by 2. If your triangle you multiply by 2, it means also the rectangle you need to multiply by 2 again at the front and also at the back. So let's move. Okay, so we are moving to raking and cutting again. So raking and cutting, we focus on this length, the length of the raking and cutting. It starts here and then ends there again. So that is the length of the raking and cutting. You do not take the length of the rafter. There is no raking and cutting here. Again, so the length of the raking and cutting is from here until there. So we have 2159 as you can see again. So 2159 here, it is of drawing. So this is the length of the raking and cutting from there until there, which is 2159. So raking and cutting, if we were to put bricks again, Again, you can say here, we're gonna let the bricks 110, 220, 110, 220 again. But here at the corners, a 220 wall, a 220 brick cannot fit here again. Meaning for it must be cut again into pieces. So it must be cut for it to be able to fit there. So that is raking and cutting. So raking and cutting, you focus on the length of the raking and cutting, not the length of the rafter. So our length of the raking and cutting is 2159 again. So it's 2,16. 2,16. So this 2159 is only for this side again. So if there's 2159 here, the raking and cutting, it means also this side they'll be raking and cutting again. If this side a 220 brick wall cannot fit, you don't leave this leave this side a 220 wall, a 220 brick wall cannot fit in here again. So that if we have 2159 this side, also the other side there is raking and cutting again. So it means it's going to be 2159 multiplied by 2 for this side and the other side again. And remember, this is only at the front. Remember at the front file, this is raking and cutting again. The 220 wall, the 220 bricks are not fitting at the corners again. So there's raking and cutting. And then if there's raking and cutting here at the front, it means also at the back, since there's a gable wall, there's also going to be raking and cutting again. Yes. So you need to multiply by 2. So this 2, it's for this side and this side. And then the other multiplied by 2, it's for the front and at the back again. Okay. What's next? The beam filling. Beam filling. Okay, so let us go to page 70. So in page 70, they say the beam filling is a half brick wall built from under the wall plate. So the beam filling starts where the wall plate starts again, and it takes half the size of the wall. So again, we have a 220 brick wall, and then we have a wall plate that takes half the size of the brick wall again. So this other half is for the beam filling again. So the beam filling starts where the wall plate starts, and it takes half the size of the wall. So this here is our beam filling. Okay, let's continue. The beam filling is a half brick wall built from under the wall plate up to under the roof covering. Up to under the roof covering. Okay, and then it closes the gap between the ends of the superstructure wall and the roof covering caused by the rafters and purlines or battens. So what is the height of the beam filling there? 257. Where does it end? Here. It ends here, the 257 again. So the beam filling, it starts under the wall plate until here. Where the purlines end again. Yeah. So then we had the way where the purlines end. Again, purline, I assume it starts here where the rafter starts again, and then until there. So that is the height of the beam filling. It starts under the wall plate until here where there's the purline. So that is the beam filling. But the beam filling, it closes the gap between the ends of the superstructure wall and the roof covering caused by the rafters and pillars. So the height of the beam filling is 257 again. Okay, and then what is the length of the beam filling? How do we calculate the length of the beam filling? How do we calculate the length of the beam filling? Beam filling, first of all, is it internally or externally? Does it include the wall or it doesn't include the wall? Hmm? Beam filling. Do we include the wall when we calculate the length of the beam filling, or we subtract the length of the wall for beam filling? How do you calculate our beam filling? Okay, so I'm beam filling again. We have 6,440 here. This is the size, this is the length, that is not including the gable end again. So the beam filling, you take length that excludes take length that excludes the ends, the gable ends, the gable ends. So the length that excludes the gable ends, okay, which one? This 6440, I want to use. So the length is 6440. So in this 6440, we need to subtract 2 off to 20. We need to subtract the wall. Subtract the walls. What do we have? What's the answer? 6440? 6,000. So we have 6,000. So that is how we get the length of the beam filling. Length of beam filling, you take the length that is excluding the gable ends, okay? You take the length that is including the walls again, and then you subtract the walls. So what's the okay? It's 6,0,0 again. So beam filling it's square meter, right? So if it's square meter, it's the length and the height. So what's the height of the beam filling? We said the beam filling starts under the wall plate again. Now where the wall plate is starting, also the beam filling starts there, and then the beam filling ends here again. So now we have the height is 257. So 257 what is 0.26. So beam filling, remember, okay, we are saying that this is the beam filling again. This part here is the beam filling again. So the beam filling here it starts there and then until here. This is where the beam filling ends again. Yeah. So we have 257 from here to here. So remember that we have drawn a half truss again. So if there's a beam filling here on this side, if we were to draw a full truss, having the other side will also be what? The beam filling again. Also that side will be a beam filling. So what do we do here? Multiply by 2. Why do you multiply by 2? For two sides, okay? Okay. Are we done with the beam filling? What comes after beam filling? Facings on the beam filling. Facings on beam filling. Remember that facings is the part that we're able to see again. Facings on the beam filling. So facings on the beam filling, Leona, is square meter, right? Okay, so the length of the beam filling remains the same. It's 6,000. What is going to change is the height, okay? And then also the multiplied by 2 doesn't change. So what changes is the height. So the height will not be 257. This height here, 257, is the height of the beam filling from under the wall plate until where the pillars end. Again, you keep the beam filling and make it the height. But then okay, this one you fell here at the corner again. And the 195 you fell. So the facings of the beam filling. Here 195 figure. 195 can. So it's the 195 from under the wall plate until here at the corner. This is the facings of the facings on the beam filling. Height of the beam filling starts under the wall plate until where the pay lines end. This one here 195 is not ending where the pay lines end. Keep more connect like one more connect wall at the corner of the wall. So it's 195. So that is the facings of the beam filling. We are not able to see this part. So beam filling, the facings on beam filling, we're talking about the part that we're able to see again. So we're able to see until here. So it's 195 again. Height of the filling and height of the facings of the filling are not the same. So facings, it is 0,20. Again, it's 195. Asia? Okay, now we move. Let's go to the wall plate. Okay, so the wall plate, Leona, it is the same length as the beam filling again. It's also internal. So wall plate is 6440 minus 2 of 220. There's no need to calculate it because you already did it again, mother. Let's just do it. So it's 6,000. So it's 6,00. That is the wall plate. Same size as the beam filling. I get it, they're in the same position. So it's 6,000 Leona. And then You close the bracket. Do we multiply ka 2?
Yes.
Multiply the wall plate ka 2. We are done again. We open another bracket. They told us that our wall plate is pre-treated again. So the treatment wall plate treatment to wall plate. So the treatment to wall plate, let us go to the specifications. So in the specifications, they told us that the wall plate is 114 by 39. The wall plate is 114 by 39. So we need to calculate the girth. Again, we need to calculate the girth. So how do you calculate the girth? You find the perimeter, which is 2F plus 2B. So the length is 114 again. So it's 114 plus what is the breadth? It is 39. What do we get? 306. So the pre-treatment wall plate, you're going to take the length, which is 6,00, and then you take the perimeter, which is 0,31. So the treatment wall plate is the length and the perimeter, which is the, we can say it's the height, okay? Okay, so it's the length and then the perimeter, you underline. Do you multiply that with?
Yes.
Why do you multiply that with the treatment wall plate?
Because if one more plate is pre-treated,
The other one will also be pre-treated, so multiply by 2. So instead of the height, let's see, it is the width. So it's the length and the perimeter, yeah? Length and perimeter, length and width. So our length is 6,000. Length of the wall plate is the same length as the been filling again.
Yes.
And then pre-treatment wall plate, it has the same length as the wall plate again. Wall plate, it's just the length. You multiply by 2. Again, if we have a wall plate here, we also have a wall plate on the other side. Remember that this is a half truss again. And then we multiply by 2. For the treatment wall plate, you need to calculate the perimeter. They will give you the dimensions of the wall plate again. If they don't give you 114 by 38, you use 114 by 38. So we are done with the wall plate. What's next? After the wall plate, we go to the pay lines. So pay lines, remember that there are 2 different kinds of pay lines again. Okay, we have Eve's pay line and then we have this one here, Son pay line. So we are going to start with the Son pay line. Son pay lines, are they external or internal? External rather we include the walls again. Internal rather we exclude the walls. So pay lines, are they internal or are they external? External. Okay, so we have 6440. We just say it's 6440 fella. Plus 2 of the gable lines again. The pillar is starting up the external, they start here again until there. So they take the dimension of the whole entire roof. So we have 6440 plus 2 of the gable ends. What do we get? 6640. So it's 6640. 6 comma
64.
6 comma 64. Do we multiply our pay lines or we just leave it like that? We do multiply our pay lines again. Usually the pay lines will take like 3 again. So it's 1, 2, 3. When we say it's 3 pay lines, we are not including the if pay line again. This is the if pay line. The if pay line is the one that is here. More the overhang again at the eaves. The eaves pay is at the eaves. More the overhang. So here it the pay line. So if more over 4 pay lines, on the pay lines you don't say you have 4 pay lines. The pay lines each the sun pay lines each dealing more with you, and then the if pay line here it's at the corner again. So the if pay line is 1. So the pay line is 1, 2, 3. And then if on your roof they did not draw the pay lines, just multiply by 3 again. So we have 3 pay lines. And then if we have 3 pay lines, remember that it's 3 on this side file again. So we need to multiply it's also 3 on the other side, right? So it's also 3 on this other side. So multiply by 2. So are we done with the pay lines? Okay, we underline, we go to the is per line. Is the length the same? Yes, the length is the same, so it's 6 comma 6 4. Hair lines are externally award. You can see that the hair lines are they include the walls. I get the end. I get more. There's an if hair line. You know the whole roof, the length of the whole roof, dimensions of the whole roof will show. So 6 comma 6 4. We multiply by we multiply by 2. If per line it's 1 on one side again, so whether you write 1 multiplied by 2 or you just write 2, it's okay again. So we have 2, we have 1 on one side and also 1 on the other side. So we have 2 if per lines on the roof, on the whole entire roof again. It will give 1 more, the 1 more. So are we done with the if per line? So we are done. Okay. Okay, let us continue. Now we go to the trusses again. Trusses. So for trusses, we need to go back to the specifications. Let's go to the specifications. On the specifications, they said the trusses are spaced at 750 millimeter centers again. So when you deal with trusses, you need to check or refer to your specification and check the spacings of the trusses again. So for the trusses, which length are we going to use? Trusses are internal, not external again. Now the trusses are not including the walls again. So we have 6 for 40. We need to subtract the walls. So write on your notes that trusses do not include walls. So meaning if you have a line that is including the walls, you need to subtract again. So 6 for 40 minus 2 of 220, what do we get? 6,000. So that is the length of our trusses. And then now we need to use the spacing that they gave us on the specification. They said it is spaced at 750 centers. So it means you're going to take this 6,000 again. So 6,000 divided by 750. What do we get? You take the length. It's length divided by the spacing. What do we get? 8. So we got 8. So let us look at my finger, my hand. So this is my hand. I have 5 trusses. I want 5 trusses equal to 5 fingers. So I have 1 space, 2, 3, 4, 5, 6. I have 5 fingers, but I have 6 spaces. 1, 2, 3, 4, 5. 5 fingers again. But spaces 1, 2, 3, 4, 5, 6. I have 6 spacings again. Also for the trusses, if your trusses are 5, you need to add 1 for spacings. As you can see, I have 5 fingers, but I have 6 spacings again. So if you have 5 trusses, you need to add 1. So here we have 8 trusses again. We have 8. You need to add 1. This one is for the number of spacings. I have 5 fingers. Here it is. I have 8 trusses. I need to add 1. 5 fingers, 1, 2, 3, 4, 5, 6 spacing. So we add 1. It's equal to 9 again. So it means that our number of trusses is 9. 9 number of trusses. This is the total number of trusses that we have. It's 9. So when we are dealing with trusses, there are lengths for trusses again. So there's a length that is not exceeding 2,4. There's a length that is exceeding 2,4, but not exceeding 3,6. Is it 3,6 or 3,9? It's 3,9. 3,9, and then there's a length that is exceeding 3,9 but not exceeding 4,4. Again? Okay. So we are going to start with the trusses that are not exceeding 2,4 again. So you look at your half truss. Trusses, when we are talking about trusses, we are talking about king post. We are talking about the rafter. We are talking about no, not the rafter. It's king post, is the tie beam, the queen post, the diagonal strut, the rafter. What else? So it's the rafter. Everything else is it's on the roof. So we have the tie beam, we have the king, we have the diagonal strut. This is the queen post again. We have the king post and then the rafter. So it's 1, 2, 3, 4, 5 things again. So let us check. King post, here it is. The length of the king post is 1145. Is it exceeding 2,4? Okay, so it means we are going to group it. We are going to, you write the description there, and then now just summarize, not exceeding 2,4. So the ones that are not exceeding 2,4, we are going to start with the king post again. So king post, what is the length of the king post? 1, 1,15. Again, it's 1145, so it's 1,15. How many king posts are there on a roof? It is 1 again. This is our roof. This is the king post again. Then the diagonal strut, the queen post, diagonal strut, the queen post. We have 2 queen posts, we have 2 diagonal strut, but we have 1 king post again. Here it is, 1 king post. Even if we were to draw a full truss there, it will still be 1 king post again. So there's no need to write our 1 there. So it's 1,15. You need to multiply by your number of trusses. So how many number of trusses do we have? We have 9 again. Okay, we are done with the king post. What else falls up under the trusses that are not exceeding 2,4? Let's check the king post. It's 703. It is not exceeding 2,4. So we need to group. Tomaka not exceeding 2,4. So it's the queen post. The queen post is 0,70. And then we have 2 queen posts again. So we need to multiply by 2. And then we have 9 number of trusses. Again, these are trusses. The reason we calculated number of trusses was for us to multiply every truss by the number of trusses again. So not exceeding 2,4 we group. We have the king post, it's not exceeding 2,4, it's 1,15 again. We have 1 king post, so there's no need to multiply by 1. And then how many number of trusses do we have? 9. So every truss we need to multiply by the number of trusses again. We move, we go to the queen post. We got 703. How many queen posts are there in a roof? We have 2 again, hence we multiplied by 2. And then the number of trusses again. So let's check what else is it that is not exceeding 2,4. Where is the strut? Okay, here it is, the diagonal strut again. It is 1 diagonal strut. It's 1035, so it's 1,04. How many struts do we have in a full roof? 2. Yes, we have done a half truss here, but when you take off, you do not take off using the half truss again. You take off using a full truss. So yes, here we are able to see a 1 diagonal strut, but in a full roof truss, how many diagonal struts are there? There are 2 again. So multiply by 2 and then multiply by the number of trusses, which are 9. Is there anything else that is not exceeding 2,4? No again. Okay, you can copy here.